In this and the following videos, we will look at inheritance, which is an integral feature of most object-oriented programming languages, including Java. In the context of object-oriented programming, when we refer to inheritance, we often mean the mechanism that allows you to create new classes by extending existing ones. In this case, the already defined class is called a superclass, and the new one would be its subclass. This allows two things. First of all, it allows you to create a level of abstraction in terms of is-a relationships, in the sense that every instance of a subclass, every object of that subclass is also an instance of the superclass. The subclass is a special kind of its superclass. And secondly, it allows you to reuse some of the code. And this is because every subclass inherits methods and attributes from its superclass, and therefore it only needs to implement what's new. Imagine you're writing a program that involves colorful circles, squares, and equilateral triangles. Those will be instantiated based on their respective classes. You're writing classes circle, square, and triangle. But all of them will have an attribute color, which is a string. So we can save ourselves some work by defining a common superclass, let's say shape, because all of them represent two-dimensional shapes. And that superclass already has this attribute color and its getters and setters, for example. And now all of these three classes will automatically inherit the attribute color as well as their getters and setters. So we don't need to write anything regarding this attribute in any of these subclasses. Similarly, you could add an intermediate class called polygon that is a superclass of square and triangle, but still a special case of a shape. And that class polygon, for example, could implement this method area based on some common formula, and therefore you would not have to implement this method in the subclass square nor in the subclass triangle because it's already implemented in the superclass. Such a tree here is called a class hierarchy, and in UML class diagrams the open arrow indicates a subclass relation. Let's look at the Java syntax for creating a subclass based on a superclass. We will use the keyword extends followed by the name of the superclass. So in line 1 we are defining the triangle class as a subclass of the polygon class. Notice that in line 3 we don't really need to declare that there is this public integer attribute color because that is already inherited from polygon and shape. And similarly, we don't really need to introduce a public integer attribute corners because that's already inherited from the polygon class. But we would need to introduce all the new attributes and methods that aren't inherited. So for example, in line 5, we're creating a new attribute called side, which is a double that is only present in the subclass triangle but not present in the superclass polygon. A word on single versus multiple inheritance. You could imagine that it's useful to have a class being a subclass of multiple superclasses. For example, triangle could both be a two-dimensional shape and also a musical instrument. Then it would inherit attributes and methods from both these superclasses. In Java, that isn't possible. In Java, every class has exactly one superclass. So we are looking at single inheritance in Java versus multiple inheritance, which is possible in other languages such as Python and C#. There's only one exception, which is the class called object, which is the implicit superclass unless you're declaring a superclass, and therefore this makes object the root of all class hierarchies. Every class is a subclass of the class object in Java. Now, what exactly is inherited from a superclass to a subclass? The answer is every class member that is declared public or protected. And that means attributes, it means methods, but it does not include constructor methods. Constructor methods are technically members of the superclass. So attributes as well as methods get inherited as long as they're declared public or protected. Okay, but what exactly does protected mean? Well, it's a new modifier that you can use when you're defining your methods. And it's similar to private. So similar to private fields or methods, protected ones cannot be accessed from the outside when you are dealing with an instance directly. So you cannot access, for example, c.color from outside the object in case color is protected. But different from private fields and methods, protected ones are inherited. Private fields and methods are not inherited from superclass to subclass. A quick word on UML diagrams. We would use the hash symbol to indicate a protected field or method, where we used plus to indicate public members. Finally, why is this useful to me as a programmer? Well, first of all, inheritance allows you to introduce a level of abstraction in your code, and that's always a good thing because it modularizes your code. It enhances code reuse. You can inherit implementations and therefore don't have to duplicate it. It also improves the readability of your code because lots of smaller classes that are connected via the subclass relation are easier to read than a few very large classes. And therefore, properly applied, inheritance allows you to reduce the software maintenance cost